Welcome one and all to the second part of the Radicals Overview series. In this video we're going to focus on the case where the radicand has no fractions. In order to get started though, we need to talk about two properties, multiplication and division, and in particular division. Multiplication is more of a rule that I need to bring up in order to prepare for what's going to come up in the future, and it's pretty straightforward. As long as you have two radicals with the same degree multiplied with each other, you can multiply the inside. So in this example, square root of a times the square root of b allows you to multiply the a and b together under the same radical. The big thing I want to address though is going to be this second part where it says square root of a times square root of a equals a. Whenever you have two square roots, and specifically square roots, multiplied with each other and they have the same value, the square roots cancel out and you are left with what they have in common, and that's it. Now let's talk about division, and this is where we're going to primarily focus our video on, is what if you have a fraction inside of a square root? Well, we never ever want that to happen, so we have to split the radical apart into two. We're going to do square root of a over the square root of b. So what does that look like if we have numbers? Here we go. We have the square root of 3 over 16. I want to split that fraction apart so that it is square root of 3 over the square root of 16. Once you have that rule applied, then it's just a matter of simplifying each square root individually. So we look at the numerator first and we say, can I simplify the square root of 3? And the answer to that is no. So you just keep it the same. However, oops, I don't know what that happened there. Square root of 3 over, and the square root of 16, can I simplify that? And the answer to that is yes, it is a perfect square. So we just go ahead and write that. It is 4. Since there is nothing else we can do after that point, we can't simplify, we can't break it apart any further, that's our final answer, and we are done. So at this point, you're going to go to this slide right here, and you are going to practice these 3 examples on your own. So take the time to pause the video here, try it out, and then resume it when you are ready to check your work and your answers with mine. So pause it right now. And we're back. All right, here we go. So I'm going to just only scroll down to this point right here because I want to focus on the first example. We have 5 over 9. Split that apart. Square root of 5 over square root of 9. And the square root of 9 is the only thing that can be broken apart, and the answer is square root of 5 over 3. As for our second example, we have to again apply the rule, so that's square root of 200 over square root of 25. We simplify each one separately. So in the denominator, I want to focus on that because that's easier. Square root of 25 is just automatically equal to 5. On the top, however, 200 can be simplified. So the largest perfect square to 200 is 100. So square root of 100 times 2. Square root of 100 breaks down to 10 times the square root of 2 over 5. So we get to this point right here. And then you think you'd be done, but we're not, because of the fact that we can't simplify one step further. We look at the number on the top versus the number on the bottom. 10 over 5. Do not do that with square roots. The 2 is stuck inside the square root radical, so we can't touch that right now, unless there was another square root. We did all our steps correctly, so we got to this point, and we say, alright, what's 10 over 5? Well, the answer to that would be 2. So the answer is 2 times the square root of 2, and you'd be done at that point. Alright, let's go back a little bit further up to the last example. Square root of 18 over 81, split that apart. Simplify each one. So for the numerator, largest perfect square is 9, and then the other one is square root of 2. The denominator just breaks down to 9 because square root of 81 is a perfect square. So once we get to the second to last example, second to last step, 3 times the square root of 2 over 9. Now we can reduce this again one step further, so 3 over 9 would reduce to 1 over 3, because 3 divided by 3 breaks into 3 one time, 3 breaks into 9 3 times. And you don't need the 1 in front of the square root of 2 because it's pretty redundant at that point. So the final answer is square root of 2 over 3. And that's the end to this video, ladies and gentlemen. Check out the last video to this series.